So bonjour, hello. Thank you again all for attending my talk, and thank you to all the organizers for putting on the 13th iteration of the symposium. I'm Novin, and my presentation is titled The Cognitive Biases That Emerge from Search as Learning. Before I begin, here's a quick overview of this presentation. I'll be providing a standard introduction, background information, and then we'll proceed to the methods and limitations. However, one difference to note is that this dissertation is a culmination of 3 different studies, with the first 2 studies informed how to proceed to the third and final study. And because the first 2 studies are finalized, I include them in the section 2, where I provide them as background information for the final study. So since the 1960s, scholars have been speaking about the coming of the age of information, and the idea that there would be misinformation to account for is by no means new. A few of our speakers have already covered this idea thoroughly. So just to confirm, after the former USA President Trump and his daily tweets about fake news and the pandemic crisis, I don't think it's too much of a stretch to say that today we're not only in the age of information, but also in the age of misinformation and disinformation. However, the current discussions on how misinformation spreads tends to focus on a user's exposure to social media rather than how a person's own search process can lead one to misinformation. So what type of issues emerge with the search process? 2 main ones that concern this dissertation deal with the concept of opacity and biases. With opacity, students may place their trust in the search engine algorithm at the expense of their own critical thinking, despite not understanding the algorithm. And in terms of biases, they may place trust in information presented by a search engine results page that can also lead to cognitive biases. So why is it important to address these issues? Well, it's especially important for the public science literacy. As studies by the National Science Board found, more people are using search to learn and self-inform themselves about the sciences relative to traditional media. And this is great for general science literacy, but problematic if people are simultaneously increasing the amount of misinformation they learn as they search. Therefore, it's important to understand how people conduct self-directed learning using search engines and how they minimize misinformation or biases. And this leads me to questions such as, when people search for information, what cognitive mechanisms could explain how or why information is perceived as usable? And how do people go about reasoning through biases or conflicting information about science? So because this study wishes to observe how people search as they learn, the concept of search as learning, or SAL, provides a framework to investigate this phenomena. Luan Freund and others define SAL as a user-driven technology supported process of human information interaction. In this process, people engage intellectually, physically, and emotionally with digital information. And while SAL is a broad subject, important elements of SAL lie in its focus on metacognition, which is the concept of thinking about thinking, and was also covered, I believe, by Coraline's presentation. And learning outcomes and domain expertise are also important elements. Now, elements of SAL that challenge users are the value of mislearning, as well as cognitive, algorithmic, and source biases, which I'll be getting into. So to explore this area further, I conducted a study with my supervisor, observing the general student population interacting with the search process on a science topic. We identified 4 cognitive biases when students search a science topic. And then Huang, an independent researcher, replicated our experiments to show that the 4 cognitive biases also emerge with STEM students. That's science, technology, engineering, and math students, when they were researching a science topic. Finally, we wanted to see if the 4 cognitive biases emerge among students who are not only in the sciences, but had achieved a level of expertise on the specific science topic they were searching. And the 4 biases still emerged, albeit by a smaller degree. And all of these studies involved showing a mock Google page to participants where conflicting information was inserted into the search results, and then students were asked to use the search results to write a brief summary of the science topic. And just to be clear, by conflicting information, I don't mean I showed disinformation or false information. The search page was about a science topic where different groups of scientists held different scientifically valid perspectives that happen to also conflict. So basic science debates. So in this specific example about biofuels, one group of scientists writes that corn should be used as a biofuel, and a second group of scientists argues that corn should not be used. And I want to see how does the participant reconcile these two different views in a summary, and what type of errors or biases show up. And to look for the mechanisms causing any errors or biases in the write-ups, I presented the conflicting information in different document genres and orders. So a computer would randomly provide different participants with the conflicting information in a double-blind method with different document genres. And by document genre, that refers to type of source, such as whether it's written with for the public, like a Wikipedia article or a blog, or an academic article for scholars. And I also presented in different document orders. So if the conflicting information would either appear at the top, middle, or bottom. Now, these two initial studies, the two initial studies found these different biases that emerged from the interactions between the user and the SERP. And the first are priming effects. When a user opens a SERP interface, prior to reading any text, the user is attracted to familiar document genres and graphical demarcations. Next, anchoring effects take place where a user reads the top results and then anchors their assumptions. Next, as the user begins interacting with several sources, framing effects can be observed because the user is attracted to a collection of document genres that work together to frame an issue with a certain perspective. This is similar to confirmation bias, except the user is not actively looking for confirmation. Quite the opposite. It's just that the familiar genres happen to agree with each other. For example, many popular science articles will focus only on corn biofuels other than different types of biofuels, and that will create a bias. So with framing, what we found was that when the conflicting source on a science topic was placed at the top of the search page, 73% of participants included the science conflict in their summary write-ups. However, when the conflicting source was in the middle or bottom of the search page, only 45% of participants included the science conflict when summarizing the science topic. And the same pattern occurred with the experts, but with better results. All the experts would mention the science controversy when the conflicting source was at the top of the search page, but that number would drop to half if it was placed elsewhere. So comparing the novices to the experts, we see that when the controversy is placed at the middle or bottom of the search page, there's a set of participants, 45% for the novices and 50% of experts, who will mention the controversy regardless of framing. So what I want to know from my third study was how these latter participants were avoiding framing effects and how are they navigating the SERP differently. And this leads me to my RQ for the third question. How does problem framing affect the information seeking process of students working to solve open-ended information problems? So to demonstrate the third study's method of answering this question, here's a prior experiment on how framing can affect decisions. Consider the prisoner's dilemma, which is a famous experiment where scholars ask participants to make decisions in a hypothetical prison, and participants will often try to make choices based on their own self-interest. However, Liebert and co-authors found that if you frame the same task but only change its title to a community game, people will make decisions based on the group's interest. So the community game provides a frame that influences more of the cooperative actions. In parallel, this study will set up students with a search task that has an explicit problem frame and observe how it affects their search. So similar to Lieberman's study Framing the Prisoner's Dilemma, this experimental portion of this dissertation focuses on the tasks frames where students are set up with a search task that has an explicit frame and one that does not. And then I'll observe how students compensate without an explicit frame. Another way of putting it is I'll be looking at whether the task frames the user's search or the user's search can frame the task. And I'll be interested in observing which elements of a search task these latter participants use as a frame. So this third study will again use a mock SERP with conflicting results, but with some notable differences. I'll be focusing on the elements in a search task that participants use as a frame. And my last two studies show that the document order and genre can act as mechanisms. But unlike the last two studies, I'll be observing the participants' actions more closely via screen sharing, and students can explore the search pages in greater depth. And this third study will consist of the think aloud portion, where participants will explain their thought process in more depth. Finally, I'll be looking at different science topics from my last two studies that focus on climate change. And even the study by Huang that replicated our findings, he also used climate change. However, this third study will focus on science topics that are more familiar, such as the topic of cell phones. And in case that sounds a little bit complicated, here's an example of what that framing task on cell phones would look like. One group would receive the first question, should UBC restrict the use of cell phones on UBC premises? Please explain why. And then the second group will just receive one sentence that frames the question a little bit. The health of the students at UBC should be a top priority. Should UBC restrict the use of cell phones on schools premises? And please explain why. Now, there are some limitations with this study, actually many limitations with the study, because making inferences on learning based on search behavior analysis is not an exact science. Notably, it's time dependent. It's not a longitudinal study or studies longitudinal searches or longitudinal learning. And also brief searches are not tested. Other variances in search tasks are not tested as well. A search session that navigates, for example, while there's daily interruptions not being studied, or deep dive type searching won't be looked at, for example, something that researchers would be doing. The conditions are more laboratory as well. And also the think aloud method that's being used as well is limited by what can be inferred about how humans are actually rationalizing their actions. With that said, this proposal plans to inform future research on exploring cognitive biases, as well as the broader discussion of epistemological cognition and metacognition. To conclude, let me reiterate what is the greater purpose of addressing these research questions. Well, by doing so, I can address the issues I raised at the start about understanding the ways people deal with the lack of transparency in search engines and the cognitive biases that lead people to misinform themselves, specifically in regards to scientific subjects. Thank you, and we'll see.
Thank you for that presentation. I'd like to listen to question. Any question in the chat? Okay, Professor Bartlett.
Thank you, Phillips, and thank you very much, Alan, for the presentation. I'm kind of wishing we were at an in-person conference right now so that I could chat with you over coffee. Yes. I will limit my question to one at the moment, and sort of one that ties back to some of the earlier presentations. So, as I understand your methods, you were basically, I mean, you were comparing different levels of domain knowledge from the naive to the STEM students, to the expert, increasing scientific knowledge. I was wondering, anywhere in there, are you considering people's information literacy skills and the extent to which they've been educated in search strategies and in, as part of that, how search systems work?
No, that's a great question.
The earlier presentations.
Yeah, that's a great question. So this study, it didn't have to do it as much because the participants were mostly UBC students. Not that that's not an important question, but it didn't have, because the UBC in British Columbia, digital learning is taught as part of our curriculum. It starts at grade 7. I went through the curriculum and found that I do have advice for the curriculum, but they were all provided at about the same level of digital literacy, and it is taught through different grades. So yeah, so I guess, and these are UBC students, so these are students that have met certain standards in you have to submit an essay to become an undergraduate and such. You have to present critical thinking. You have to also pass some of these courses, right? So yeah. But I think that is an important question. But yeah, it was one of the questions when we were doing that second study, and we were thinking of, do we want to look more students are doing digital literacy, but because it was so science focused, we thought familiarity with the subject was really showing more of a difference than the actual digital literacy, which again, because they're all UBC students, we had a question in there that was looking at them, but it was all so similar that it was hard to differentiate. I guess though, in the third study that is a concern, right? So the third study, I'm going to be more of an in-depth look at the students. They'll be doing a think aloud. I'll be observing exactly how they search, how they navigate between searches, between search pages. And although I won't have, they'll be UBC students, so I won't know as much about their background, I'll be able to differentiate whether certain students are doing different things that maybe that could inform the curriculum, at least the BC British Columbia curriculum.
Yeah, thank you. Because it'd be interesting to look at, because I think even though they have all gone through, achieved those levels that you mentioned in secondary school and certain levels within the university itself, I don't think that necessarily means that they've actually got strong information literacy and digital literacy skills. I think, as was shown by some of the previous studies, that fairly consistently any research that looks at those skills finds that they're not.
Oh, sorry. If I said strong, I do not mean that they are strong at all. I just meant that they were equal. But they're not consistent, which is
yeah. And it would be, I think, as you're moving forward in the third study, looking at how people their mental models of what the search system is doing could be really interesting. I did a study in that, probably we're looking at 20 years ago now, actually, with Lou and Freund, where there were really interesting misconceptions about what's actually happening under the hood with the search system. And it'd be really interesting to look at that.
Oh yeah,
20 years later, and see if people have gotten any more savvy.
Well, like just looking at the search engine results page itself, like not even looking at how the search, trying to figure out the algorithm. Eric Myers, my supervisor, does a lot of this work, but also just looking at the search engine results page, there was actually an interesting study that came from Ofcom in about 2017. Ofcom is a UK, they're a communications regulatory body. And they found that students, and this was actually really surprising, so it's going through the results, and they found that children not only had an issue with sometimes differentiating between advertisements and search results, but also they had an issue with sometimes even realizing that certain results were PR releases, public relation releases, and that some people would write with actual purposeful biases.
Okay, thank you. I think I'm taking all your time, so I'll stop now, but thank you very much.
Well, we can chat about it later, yeah.
Thank you. Thank you, Alamir, for that presentation. I think in the absence of any other, okay, yes, there's a question in the chat. It says from Anton, it says, can you speak on how you define misinformation and disinformation, please?
Well, so I sort of use the misinformation and disinformation as just sort of like ladders to biases, right? I wasn't actually looking at sorry, but that was a bit unclear, but I was just speaking about the idea of misinformation to go into how do people misinform themselves with searches. misinformation, disinformation itself, those were terms that were put forward by Neil Postman, or at least that was one of the first ones. And he was talking about how misinformation is not only information that is not true, but disinformation is actually purposely written with an intention of being of falsifying information. That's I mean, those debates, those terms may be debatable, I guess, but they're not really the ones. So just to be clear, with my study, we actually didn't show them misinformation at all. We showed them information that had biases. So they were scientific valid perspectives from two different scientists that said, you know, so for example, like alternative fuels should be this way, and when a group would say no, the alternative fuels should be this way, and that will help. And there was like this disagreements. These are type of science which here were. So that was where the biases came in. But sorry if that was unclear.
Okay, thank you for clarifying.